Thank you very much, and hello and welcome once again, everybody, to Assurance Reimagined, how AI, ML and Gen AI are changing the rules. Terrific to have you with us. As always, thank you very much for coming. We know, of course, that networks are increasingly programmable and that customers are demanding ever better and more reliable services. This, of course, means operational processes need to keep pace. So in the webinar today, we're going to be focusing on how AI, ML technologies can be applied to service assurance. It's a terrific topic. I think, first of all, because, I guess as we all know, AI is not only the hottest thing in tech right now, but I think also the hottest thing in networking. So it's the buzz topic. It's what we're getting the big audiences on, and it's all super interesting. So that's great. But we're going to look at how some of these techniques, practical implementation of AI that can really help operators ensure service quality, and how Gen AI, generative AI, might play a role in future. So we're going to bring it back down to a practical level. And the third reason really is we have some terrific speakers, each with great knowledge of telco and AI and plenty of skin in the game with service assurance. So my name is Gabriel Brown. I'm a principal analyst with heavy reading on lead our mobile network coverage. And I'm joined by our two expert guest speakers, both from Amdocs. So first of all, I'd like to ask Yuval Stein to introduce himself. Yuval, if you're there, could you turn on your camera and mic and introduce yourself, please?
Thank you, Gabriel. Hello, everyone. I'm glad to be here with you today. I've long year experience in service assurance. I held various positions of product management and technology management in this area. Lately, I've been focusing on AI machine learning solutions for service assurance, which is what we'll discuss today, at least part of it. Thanks.
Good stuff, Yuval. And then Asher Besserglick.
Hi, everyone. Glad to be here. I'm an AI software principal here in Amdocs. I have many years in the software industry and telecom specifically, and working with AI for many years now, and now focusing on generative AI and network operations and network assurance applications. Thank you.
Good stuff. Thanks, Asher. So the agenda's pretty simple. I'm going to do two very quick slides of introduction, and we're going to hand over to Yuval, and Asher will follow up. They have a terrific deck, great graphics, loads of dense material and so forth, and a really good presentation for us. But I know they're also both open to taking questions. We should have some time for that at the end. And maybe we'll take a break midway or something, see if there's something people want to jump on as well. If you want to ask them a question, please do put it in at any time. There's a little text box on your screen for Q&A, and I'll keep an eye on those at the back end as they're talking and try and put it to the speakers here. I know they're both really open to taking questions, have a lot of expertise, and just to sort of to frame this properly, any question you put in here, I will not read out your name or your company name when I ask the question. I'll just ask it as an anonymous question. So do take advantage of it. I think we've got some great material, but these things are always better when we have some audience interaction as well. So with that, we're going to push on to the introduction here. I think it's a pretty simple setup. We all know networks are complex and produce huge quantities of telemetry data, and that this combination now is really pushing the limits of what classic processes and algorithms and so forth can handle. On the upside, of course, there's a huge amount of training data and priors coming out of networks, so there's a lot to work with. At the same time, I mean, we can debate the timeline a little bit, but certainly over the past 10, 12 years, we've seen incredibly rapid development of ML/AI technology with all the different acronyms you see on the chart here. I was talking to Asher just before we went live. He's been in it a good bit of time longer than that. But there's been huge advances, really. It's really quite incredible. Now, within this, there's obviously an important role for networking within training clusters, for example, in the data center mainly. But then as we look out a little bit, we can see roles for telcos, but potentially as we move to federated learning and inference at the edge, or even on-device inference, for example, could bring in the telco network more directly, as it were. I think one area, of course, that this is already being applied today is in telco network operations. There are many domain-specific opportunities here really across the network lifecycle that look like they can deliver some pretty tangible gains. You could, for example, have a 10 to 15% more efficient paging algorithm, or many examples of this. Quite clearly, service assurance is a prime candidate for this. It's our focus of our webinar today, so we're going to be deep diving on that. I think I'll just have one comment a little bit as we look a little bit longer term, not so much what we're doing today, but we have this idea of AI native networks is around. And so an example of where there's a map across to LLMs and Gen AI and all that research. For example, now we have researchers looking at how you could use the transformer technologies developed for LLMs and apply that to time series data and communication links to produce, let's say, a better or more adaptable encoder. Now, stuff like that is very much for the future and in research phase, but it's really interesting how these base technologies could and potentially will be applied deep into networking and all parts of the stack really as we go forward. Moving on, back down to earth a little bit. Service assurance is a domain. I think really we best say a set of subdomains in which AI has the potential to make some noticeable improvements. We've discussed a bit, how significant they are. The challenges here are pretty well known. Starts with the data generated at the network function level and comes out in many different formats, even though it's passed typically through an EMS or an NMS. And service assurance systems essentially use this data to identify problems, suggest remedies, and so forth. It's really a critical process. I think we need to be a bit careful. I don't think we should characterize this as a broken model or anything like that. I think, some operators have really quite impressive, terrific capabilities really that make a super positive impact on customer experience. So it's not a question of saying this is a broken model. But there's certainly work to do as well. The assurance is, as I mentioned, very often split into subroutines. Ultimately, for an operator to get an end-to-end view, it's a lot of work. You have to work on the data, you have to work on bringing systems together, and so forth. And it can be a little backward-looking and reactive to problems. So I think it's fair to say, as the industry evolves service assurance, bringing in some of the new technologies and new approaches makes a good deal of sense. So with that, I'm going to actually hand over now to Yuval Stein at Amdocs to take us through that in a bit more detail. Yuval, your first slide is showing. If you turn on your mic and camera, you have the controls. You can get underway.
Okay. Thank you very much, Gabriel. I hope that you're able to see and hear me. So indeed, I would first like, following what Gabriel said, I would like to talk a bit more about the challenges of the modern service assurance, since the needs for analytics, for AI and machine learning, comes a lot for the more complex network that we need to manage. And I'll give some examples from 5G. So if we look at what we need to do with 5G, we have some new challenges and technologies here that we need to assure. So first of all, 5G comes with various or different use cases that each one of them needs to be assured with its own specific requirements, like the high bandwidth or EMBB, URLLC, low latency, and massive IoT. And we need to assure each one of them specifically, and this is being reflected in the network slicing technology. Then we have other parts of 5G that are newer, like CRAN and Open RAN. We have the addition of the mobile edge computing to the mobile architecture. So it's not just the core and the access, we also have the edge. So the entire architecture is more complex. Naturally, looking at how service operators deploy 5G, it's not all alone. So part of the challenge is to assure 5G aside the existing network technology, whether it is LTE or other existing technologies, and There are some other new technologies and requirements involved with assuring 5G, like virtual and cloudified parts of the networks, like the higher volumes of assurance data that we have in 5G, and actually this is increasing with each generation of mobile technology. And then we have the automation requirements of doing closed loops and other other automation. So it is simply more complex. If we look at the evolution of service assurance, in particular when we look at end-to-end service assurance, we see like a pyramid of functionality that is going from bottom up. So traditional service assurance is built, as you may all know, it starts with collecting assurance data like alarms, measurements, usage records, logs, and other types of data. The data is manipulated, and then traditionally we have the monitoring applications that are provided to operations and engineering, whether it is the NOC, the SOC, or other engineers that are involved in the operations, which is what we have in service assurance for years. Now, the upper layer are becoming essential. So to deal with the complexities and quantities, we need the analytics on top of that. So we need a set of algorithms that will serve the bottom layers. And this is actually the baseline for the next layer, which is the automation, as the automation needs the results of these algorithms. And that paves the way to autonomous networks and autonomous management, which eventually we would like to have more and more of it. So AI machine learning is changing the rules, and why are we doing it? And first of all, because we have to. So we mentioned already the complexity of the networks. We slightly touched the higher data volumes, and humans are just not enough for it, both because of the quantity and also the complexity. So it just that it's too complex for people to solve all these problems. Secondly, is because we can, because using analytics is becoming easier and more beneficial. The ROI of this is increasing since the compute power cost is getting to levels that we can use. AI machine learning is because more relevant data is becoming available and accessible, and mainly since the applied math and the algorithms are progressing very fast. So we have the deep learning techniques and the neural networks, different architectures, and these are available for us today, and they were not available in the past. So we can use them to the benefit of management in general and of service assurance specifically. So these were like the key challenges, and now let's go to the solution side. So I'll talk a bit the rest of the time about AI machine learning based solutions to be used by service assurance. What I'm presenting in this slide is a list, which is of course a subset of possible solutions. These are solutions that Amdocs is offering. And there are more solutions, but probably the main use cases that we have in the industry today are here. I can mention some of them. First one is predictive failure recognition. We have like new families of predictive algorithms, and with deep learning, looking at the historical behavior as reflected in assurance data. We can have models trained to predict future service impacting alarms. So this is one use case. A second use case that is very that we have in the industry for long years is root cause analysis and related clustering. So the use case is well known, but with the new techniques, we can get a better and much more efficient root cause analysis. The challenge is all the solutions are new. And then there are other use cases here. I will not go over in details on all of them, but if we look at some that are more with the performance management information, counters and KPIs, we have things like trends analysis, anomaly detection, dynamic self-tuning, thresholding, and other related solutions. In the next slides, I'll go deeper to some of these use cases. First, something about the benefits that we can get from using these algorithms. So the first one, which is natural for service assurance, is reduced OpEx. If we are getting some insights from AI machine learning, then we are saving the time of humans, of the operators. We can automate some of the processes, so we are more efficient from operational expenses point of view. Another reflection or a similar point is about faster MTTR, mean time to repair. So we can reduce the time from the detection of the alarm till it is fixed, since we understand much faster what is happening there. And there are other benefits that we can get, I would say, more from the predictive side of the algorithm. So if we have predictive maintenance, or we have or we can predict problems, then we can also improve the capital expenses. And naturally, when we apply these algorithms in the area of service quality management, we can also get increased service availability, and therefore also increased customer experience and customer satisfaction. Now, let's go deeper. I would like to talk and provide two more specific examples of how these algorithms help us. The first example is about alarms reduction and prioritization. And this is quite a well-known problem in fault management. And the key thing to understand here is that alarms are symptoms. And eventually we need to fix problems. And the symptoms are just symptoms. Sometimes it's very clear from the symptoms what the problems are. Sometimes it's much more difficult to understand it. Now, this is an example. The numbers are taken from a specific service operator. But the concept here is correct, or is true in general. So in this specific case, we started from 6 million alarms, which is a lot, and of course operators cannot digest this amount. And what traditionally service assurance vendors, including us, are doing for years, we are reducing the numbers by using traditional methods like filtering, like applying policies. And in this case, we got to 196K alarms. And here we pretty much have a hard limit, coming again for the reason that these are symptoms and not insights. So there is a limit to what we can, to how much we can reduce the number of alarms if we don't use AI machine learning to understand what's really happening in the network. So by applying machine learning techniques like NLP tokenization, like alarm clustering, unsupervised ML process, exact root cause identification, and then taking it to the operational side with parent-child correlations. In this case, we managed to reduce the number of alarms by about half. It is 51% here, and naturally you can surely see the benefits when this is done. And these are algorithms that we are improving all the time, as this is really a worthy cause, and the benefit is quite understood. In short, I'll go over this one brief, how this is one way of how such an algorithm can work. There is an ongoing training that learns the behavior of the alarms, and then they are put in models that are profiles or clusters. When the online alarms are coming, then it is being identified that current alarms are matching a particular cluster or behavior. And then we actually already know to reduce the number of alarms to look at. We can then, in many cases, identify the root cause alarm within the cluster, and then we use it operationally to point on the root cause and generate the derived alarms, such that the amount of the work for the operator is reduced. And naturally, if this can be sent to a closed loop to automatically be resolved, this is even better. I'm going to a second example, which is similar from the algorithmic process, but very different in its result. And this is a predictive alarms flow. So here, the machine learning, the deep learning, is doing alarm prediction. Again, we have a training process and an offline constant training where we build models of patterns of behavior. We match the current alarms against the models that we build, and we know from the current alarms to know that we are in a situation that will lead eventually to a predicted alarm. And then we can generate a prediction that says that a specific alarm will be raised or will have a problem in hours or days, and this of course has good value. This is like one very simple example of how it looks like and the benefit. So, for example, in some cases where host is going to be down, we'll start getting alarms saying that the host is not responding. At some stage, we also see that, at least in this particular example, the host moved to a UPS, which means that eventually we are going to lose the connectivity to the host and the host will be down. And then this sequence of events will typically lead to a case of a host down. With this particular algorithm, there are parameters that can be measured related to the prediction, like the time, the warning time for the prediction, the confidence that we have in a prediction, and the level of coverage, and these are contributing to the understanding of these predictions. So this is the second case that I wanted to talk about today. And to conclude my part, I would like a bit to summarize. So these AI machine learning algorithms, they come on top of the service assurance as a part of it. Our service assurance is composed of 3 products, which are fault management, performance management, and service quality management. And to get the benefits that we discussed earlier from an end-to-end point of view, it's very beneficial to have all the 3 together, especially when you look at the algorithms and the data sources, they contribute to each other. So if you have, for example, alarms and the performance data at the resource level, it helps you to understand what's happening with your services. If you would like to get a more comprehensive picture about what's happening in the network, it's good to use both alarms and performance measurements. So these 3 products together with the overlay of the solutions and algorithms that part of them we discussed in previous slides, that gives extra benefits to your service assurance. I believe that this concludes my part, so thanks.
Good stuff. Thank you, Yuval. Don't be so quick, though. I mean, I just want to jump in before we hand over to Asher to remind everybody that we're going to have Q&A, and you can ask questions, put them in the chat box on your screen, and we look at them in the back end while Asher's talking. Yuval's going to join us for that, of course. But Yuval, before Asher goes, I already have a question for you here, and I'm, in the spirit of taking these, let's go for it right now.
Sure.
So the question is on your sheet. The question is from European Operator. On your sheet 4 here, I'll put the chart up, is a question of where do you step in with AI ML? It looks like you start at the analytics level, but I would imagine to start at the level of manipulation, or better, not to manipulate, but to let AI do the job. I think that's to do with the data sourcing, right? I'm going to push the chart to the audience at the same time. I think this must be the one the person's talking about. How would you respond to that?
Yeah, so I think it's related to the topic of correct data in general. So I didn't get to the details of these algorithms, but in some cases, indeed, the algorithms goes lower in selecting relevant data. So these algorithms are not just for the application level, but we have some algorithms that are going deeper to select, for example, the more relevant data to be used. So that's not always possible, and that's of course where it works in specific contexts. But I think that the question is very right, and indeed. That may start at a lower level sometimes.
Okay, good. Look, I'm going to try one more, Yuval. If you think you just need to think about this or hand it on, maybe Ash is going to talk about it in a moment, but let's try you on the question. Question is, I just heard the use of LLM tokenization. Could you elaborate how tokenization with LLM is being used?
It was
specifically for RCA, for root cause analysis using alarms and data. Could you take that now, or do you want to have a think about it?
No. It was NLP processing, native language processing, not LLM. So the okay. Natural language processing helps to better understand the alarms, and that was the context. LLM is related to the next part.
Yeah. Okay, tell you what, Yuval, you have a look at some of the questions in the back end, send me a back end message, and we'll push on and hear from Asher. Asher, you're on your first slides. When you put your mic and camera on, you'll be in control.
Okay. Thank you, Gabriel. And thanks, Yuval, for talking and presenting all the great stuff that we're doing on AI and machine learning. And recently, in the last few years, the emergence of generative AI algorithms with LLMs and with foundation models presented us with great opportunities to have new and exciting tools to leverage our offering to do things that allow us to interact better with people, interact better with operators, and generate content and manage content, which is either textual or more complex in terms of structure. And we're going to talk in the next few slides about how we do that and what are those things that we do. Starting with what can GenAI do for CSPs, there are quite a lot of services that can leverage the use of GenAI, going from content creation to generation of new data, manipulating data, be part of the sales processes, business recognition, and of course the operational support. If we dive a little bit into that, the main areas that we can see direct benefit is looking at human interaction, looking at analysis of documentation, logs, faults, configurations, creating and talking about reference documents like training and playbooks, suggestion, recommend new solutions and new operational functions, and automate and interact with the network itself. When we go deeper into those use cases, we can start from low to high, or from the more simple to the more advanced, more complex, starting from simple chatbot-like, copilot-like operations of finding things, asking human-like question, or being part of a human interaction conversation about what are the services that are impacted, what are the resources that I can utilize, find me a resource, find me something that I can use to create service, and so on and so forth. From finding and asking a simple question, we can go into answering more and more complex question on impact on users, impact on customers, impact on services, regional impacts, recommendations on what we can do and how to do it, getting into more elaborate playbooks and generating them as we go. And then to the highest, more complex types of use cases, going to a complete set of instructions, reapplying complete configuration, generating complete configuration, modeling network setup, changing topologies, and create new configurations and new systems based on past events, current status, and where the network needs to go. So if we go here left to right and up to down, we can see things that are more and more complex and more hard to do for humans, where GenAI can come in, jump in, and assist. And we'll go into one of these cases in more detail in a second. So when we look at operational assistance, we can look at a Copilot scenario for operation, walking through a case where we're going to do a predictive analysis for some issues that might happen on a specific customer. So when we want to look at what are these issues, it's a very open question where Copilot can interact with the human and get some deeper understanding of what can be done, then tracing it back to our predictive algorithms and our AI algorithms to predict network issues, and then assign that to service, to customer, and to impact. Once we have that, we can go and deeper dive and see which of them and get to deeper understanding and deeper analysis and explanation of what will happen first, and some explanation of what that means. And then as we move on, using generative AI, we can look at the impact analysis, we can look at the probability analysis, and based on that, we can go further and ask for recommendation, ask for question. The system can generate those recommendations for us. It can create the action plan and even provide recommendation of which of those action plans are the best to choose from. Then using the same interaction, we can go ahead and activate some of those cases, and the system will be able to orchestrate and operate all of this for us. So this is one scenario-like operation where GenAI can bridge the gap of human understanding, human interaction, and human operation with the network. Going back to the technology stack and where it plays, when we look at the future of generative AI and how it will play out in the market, we see that it will not necessarily be a very generic usage of models. It will be very specific and domain specific, meaning it will be, in our case, telecom specific, operation specific, and very oriented and augmented into the specific domain that we want to operate in. And here in Amdocs, this is exactly what we're doing in terms of the usage of the technology and adopting the technology into the service and into the functions that we have. And the way we do it is we're creating a telco-grade generative AI framework. We call it a maze. And this is a telco-specific, telco-grade platform that allow us to harness the GenAI technology and provide it or service it to the operators. And how this platform look in a very, very high level. So we segmented into three various layers. First, we're looking at the foundation generative AI layer. We're looking at GenAI models and LLM modules, and we offered that to our customers in a packed telco-grade framework. On top of that, we offer the Amaze framework on top of that allow our applications and customer applications to run on top of the foundation models. We offer the integration of telco taxonomy and bringing this technology directly into the telco domain. When we talk about taxonomy, it's highly critical to make the system or the engines tuned to the context in which they operate. So consider just a few cases when in your day-to-day discussion, when you use words like port or slice, you have very specific meaning to what it means. So in your day-to-day conversation, port will get you to the airport or the seaport, and slice will already get you thinking about something that has a lot of carbs in it and taste and specific flavor. But when you go to the telco domain, port means something completely different. It means something that you plug in a connector into, and it does something either virtual or physical. Same goes to a slice in the 5G domain. It's a completely different concept. So adjusting the taxonomy and adjusting the context into the specific domain and the specific realm of the of telecom is something that is super critical for the system to be effective and accurate. Additional enhancements are to have and provide complete packaging and kits for those use cases where we fit that into the different needs and requirements of the different apps and the different use cases. And that covers, first and foremost, the telco grade functionality, meaning it has to be scalable, it has to be redundant, it has to be protected, it has to be secured, it has to fit regulation, have to fit legal requirements, have to endure privacy requirements, all the good things that we know that telecom systems has to comply with. And then it offers the specific use cases in which we use those systems in the telco domain on top of the taxonomy, which puts it in the right context on the framework, which gives us much better and easier integration, and on top of the technology core itself. So we covered governance as well. So from Amdocs technology perspective, we are not just working on building our own technology, we're also building a very strong partnership and a relationship plan. Our latest and greatest PR and that was our initiative with NVIDIA, which is also a leader in Gen AI development and GPU hardware development for this environment. When we build those relationship, we enlarge and enhance our ecosystem to provide more technologies and more capabilities into our framework and into our offering. That's about it from my perspective. So going back to you, Gabriel.
Okay, good stuff. Thank you, Asher. Let's just push this on to the Q&A. So everyone watching, you can submit questions. The more the merrier at this stage. Thank you, Asher. Question from my side to start with. You talked there about the foundation models and a need for telecom-specific models. I wonder if you could elaborate on that a little bit, and who's developing those models, who's doing the training. Certainly, I've come across that's quite a common, and I'm not disagreeing with you or anything like that.
Mm-hmm.
That there's an issue to do that, but there are also operators saying, look, for things like documentation for network equipment and network setup, we don't actually need to train our own models, right? We can use commercial off the shelf. We need to use the vendor manuals and the documentation and things, but we don't need to be training foundational models ourselves or anything like that. Could you just elaborate on what you need to do and telecom operators need to do in terms of creating the base models?
Sure, absolutely. When we talk about adjusting and augmenting models into the specific domain, there are multiple layers of tuning and training that we can do. Not everything needs to go to a full training of the model. There are tuning functions, there are embedding functions, there are context additions that you need to do. So it goes from heavy to light or light to heavy, depends on how you look at it. And the whole idea is to make those systems much more accurate and much more reliable. Because at the end of the day, if you want to ask the system, if you want to ask an LLM about a recipe for biscuits, and you get the amount of flour a little bit off, well, not too good, but not too bad. But if you ask the LLM, okay, please redeploy the next version of configuration throughout my entire mobile network, and everything goes down, a little bit bigger of a problem. So making sure you're accurate, making sure that you can have trust with the output, making sure that the context is correct, making sure that it's efficient, and you don't have to go to many iteration, which kind of derive the point of from being efficient and making the tool help you. This is where we're looking at, and this is where getting the taxonomy right and getting the tuning right matters. And it doesn't really have to be a complete retraining of the entire model, but it does have to be better tuning to what you're trying to achieve.
Yeah, Okay, good stuff. Let's have a follow-up to that. I'll go to Yuval perhaps for this one. Yuval, when you're talking about service assurance and applying the different AI technologies, are we really here talking about, we already know the use cases as you talked about in your talk, so we're just going to kind of try and improve each of those use cases a little bit, you know, and altogether that will amount to something that's worth something, if that makes sense. Is that more or less what we're talking about here? You know, we're kind of heavily optimizing an existing set of processes and use cases, or is there more to it? Is this going to end up recasting how service assurance works fundamentally?
Okay, I'm not sure how to answer that, really. I think that the challenges, maybe I'll start from the challenges side. I think that the challenges are huge. So we are talking, we have different processes in service assurance that we are trying to support. And the key ones are healing, and actually each one of them is not what it's a functional use case, but naturally it's in reality it's many use cases, and then there is like more the maintenance processes, and there is everything around SLA preservation, and these algorithms are in different ways supporting these processes. So the challenges in each one of the processes, I think that most people are talking about healing. So the challenge, for example, the part that I was talking about, getting insights instead of symptoms and getting actionable insights. So if you would like to automate service assurance process, it's not enough to get insight. You need to get it accurate enough to the level that you can initiate an automatic corrective action. So again, I don't know if someone will call it trivial, then fine, but I think that this is really challenging, and we have a way to pass, and it's true the algorithms are improving all the time, but it's a process of years until we get to the level that we can gradually get insights at the level that they turn to actionable insights.
Yeah. Okay. I'm going to put you on the spot of another question, Yuval. Following on from what Asher was just talking about, the way I understood it. Anyway, so it's a little bit of a leap, but we'll see how it goes. Maybe I didn't understand Asher as well, but quite oftentimes he's talking about the not so much the training, but the parameters and things, and massaging the data before it goes into the model. I forget the word he used. Quite often now I meet vendors and they'll say, actually, we're developing now essentially a chatbot that will include all our documentation and training and manuals and everything for our products or this set of products, whether it's radio or core or whatever. And it's a good idea, right? Because there's a lot to read and know about, and it's a great use case, great fit. Are you doing that at Amdocs with your products? It's a question of, are you eating your own breakfast, as it were?
Yes, so definitely the type, again, we didn't cover everything today, but there is a family of algorithms related to bringing the human repairment knowledge, and actually the Gen AI part. And I think that some of the use cases that Asher mentioned are definitely covering Gen AI, to my understanding, is or knows in the direction of including human knowledge and providing it more easily. So this part is also covered in Gen AI involvement, but yes, there are also other algorithms for more on the process side of it. Yes.
Okay. Question for Asher here. I think it's for you, Asher. how large is the user group of your open source project? And if possible, what are some examples of the most mature uses of the project?
So the open source project is really what we offer to our customer. So it's not really an open source in the normal way of opening for the entire community. We are building tool sets for our customers to use and for them to contribute from their applications and to their needs. So it's not open to the whole community, to the whole developer community in the world. Part of that, or a big part of that, is compliance and regulation. So we need to make sure that the code is doing what it needs to be done, doing, and also fall under all the governance restrictions that we have. So it's within our customer, let's say, community.
Got you. Okay. On that note, do you think, I mean, we had this question very often in any of the webinar, even roughly around this topic, the governance and the privacy. I was reading, obviously, your documentation as around this product. I think it's available for download in the web console, just so I was kind of up to speed on it. And obviously, you make reference to data security and sovereignty and all of that in there. Do you want to just give me a bit of an overview, and everybody in the audience, how you ensure that, you know, as customers are putting their data into your platforms, essentially, they are taken care of?
Sure. There's a lot of restrictions and regulations already in play on data in general, but also in telecom specific. So it talks or regulates in the various locations and geos on what data can be accessed and for what means, what data can be moved around, where they can be stored, who has access to this data. There's also some very strong restrictions on how you can, what type of restrictions and segmentation you do between different pieces of data, meaning using a multi-tenancy architecture, how you segment data access and how you separate data between the various tenants and between the tenants and the operators of the data. So that there are a whole bunch of restrictions and requirements that you need to adhere to, and that just on the terms of privacy. When you talk about security and other types of regulations, there are a whole slew of other things. So that's all part of being a telco-grade vendor and being and offering a telco-grade platform. Okay.
Let's go to the next question. I don't know who's the best person for this, so I'll read it out and then you can decide. From a North American carrier, could someone go into more detail on how fault correlation is accomplished, especially when there are different faults, names/tags for each router vendor? For example, Cisco, Juniper, DriveNets are all different. How is the training done to support the fault correlation? Thanks. Okay. You want to go on that, Yuval, or Asha, you go for it. You're up on screen.
Yeah, I think that's a very Yuval question, so I'll let Yuval take it.
Okay.
Yeah, so I will not go to the details now, but we know to take into we have answers for that. We know, first of all, we have, even before the AI machine learning, we have a multi-vendor, multi-technology service assurance solution. So and the challenge is even there before we get to the AI machine learning. So we know to basically to unify the semantics, and this is also reflected in the work of the correlation. So our correlation does support the fact that it's coming in different ways from different vendors.
I guess that's pretty much a standard challenge anyway, isn't it? With any sort of assurance or automation system, really, you kind of have to do that.
Indeed. Indeed, that's required for multi-vendor, multi-technology solution even before you go to AI machine learning.
Yeah. Okay, question here from a company in the RAN supplier space. Hi, good session explanation. Regarding predictive alarms flow, and when speaking about end-to-end, does it mean data is collected also from the radio part and is included in the prediction? Are you including the RAN in the service predictions? I think is the question. Are you picking up all these CDRs from base stations and things?
A definite yes. We are also using these algorithms for RAN.
Okay. Let's see what else we got. Okay, I have a question, I think, for Asher, but I'll give it a go. This is, I guess, one of my own questions from a previous session we did. Asher, so speak to a few different operators who have a bit of experience in the topic, and they say one of the things they're sort of wrestling with a little bit is how they trade off the complexity of the model and the expense of running it and supporting it versus the gains you get. They're saying quite often with quite a simple model you can get almost as good a gain, but it's much cheaper to run. Do you have any thoughts on that issue? How sophisticated and complex do you really need to be here? Some of the fairly consistent feedback is you don't necessarily need GTP4 style model to optimize one of these processes. You can do with some simpler ML systems.
So as someone very smart said before, it's all relative. It really depends on what you want to do with the system, what you want to achieve, and how complex are your question and analysis, and how accurate you want to be. So if you just want to get a very simple chatbot around a one single app and do human interaction, like an NLP interaction instead of clicking the UI, you're probably right. But if you want to do a very deep analysis of various types of logs and various types of human feedback into trouble tickets and chat information and integrate a lot of different sources, you probably need a larger model to interact with all of these different types of data and understand them, correlate them, and get something accurate out of it. Same goes for the complexity of generating something that is big and valid, like a whole set of network configuration or even a whole set of network design. So the more accurate you want to be, the more elaborate you want to be, the larger you want to be, you need to get into these larger models, and also the value that you get is much larger, so you will be willing to pay more. So again, it's all relative. Depends on what you're trying to do. It depends on how much value you see in this action.
Okay, good stuff. Thank you very much. So look, we've got 1 minute, so I think it's a good point to close the webinar here. Just really want to finish by thanking Yuval and Asher. Yuval, thanks very much. Yuval Stein.
Thank you.
And Asher as well, thank you. With that, thanks to everybody in the audience. Webinar will be available for replay in about 24 to 48 hours. Great to have you all. Thanks especially to those of you submitting questions. Thanks very much and goodbye.